Pick the graph of the following function. So before you grab your calculator and try and draw this on the calculator, you'll probably be done if you just think about a couple of principles here. For instance, we already have the function in factored form. So the zeros are relatively easy to identify. We just take the factors, set them to 0, and solve. So that would be positive 2 and negative 1 after doing that. In addition, we can identify the multiplicity of each of these zeros. The multiplicity of positive 2 is 1 because there's no exponent on that 0. But of negative 1, it's 2. So the total of all the multiplicities is 3. So that tells me I have a degree 3 polynomial. And the leading term coefficient is positive because there's no negative number here indicating that the coefficient would be negative. So a degree 3 polynomial that has a positive leading term coefficient starts in the negative direction and ends in the negative direction in terms of end behavior. So let's see which ones match up here. So a 0 at 2 of multiplicity 1. So this one does have a 0 at 2, but it's not multiplicity 1 because if it was multiplicity 1, we would just pass right through the axis there. Since we touch the axis and bounce away, this is multiplicity 2. So that's not an option. Here we have a 0 at 2, but the graph doesn't go through 2, so this option's out. All right, we have a 0 at 2, that's correct, and it is multiplicity 1. And then we have a 0 at negative 1, which is multiplicity 2 because we touch the axis and bounce away. And then the end behavior here matches up as well, so this all looks good. Let's just check this one first. Here's our 0 at 2 and negative 1. That doesn't match up, so that one's out. And this is our correct graph.